Types of chemical bonding. ठीक है. Before I start with this type of chemical bonding, let me tell you कि A level की book में या A level के जो examiners होते हैं, वो ये assume करते हैं कि आपको IGCSE से सारी चीजें आती होंगी, ठीक है. और IGCSE से कोई भी मटेरियल उठाकर A level के पेपर में एज अ क्वेश्चन दिया जा सकता है, ठीक है. So let me give you a quick review. In IGCSE, we have three kind of bondings, right? We told you about metallic bonding, we told you about covalent, and then about ionic. To make it easier, IGCSE की बुक में हमें ये मेंशन किया होता है कि मेटल मेटल बॉन्डिंग को हम मेटालिक बॉन्डिंग कहते हैं, नॉन मेटल बॉन्डिंग को हम कोवेलेंट बॉन्डिंग कहते हैं, और नॉन मेटल की बॉन्डिंग को हम आयनिक बॉन्डिंग कहते हैं. So it was very easier for the student to take a look at the formula or the name of the compound, take help from the periodic table, come up with the suggestions why, whether they are combining metals or non-metals or both of them, and come up with the type of bonding. वो बहुत आसान था, ठीक. फिर हमने उसके अंदर जो बेसिक्स रखी या रीजनिंग रखी, that was all about stability. We told you that atoms get stable when they try to complete their outer shells. Beat the first shell. To complete it, we need 2 electrons. We defined it as duplet rule, all right? And if beat the second or third or onward shells, which we said can be stable after getting 8 electrons in their outermost shells, and we define that as an octet rule, all right? Sometimes teachers tell the name of these rules, sometimes they don't, but they do tell the student the idea of completing the outermost shell, right? We told you that there are 3 ways to complete that outermost shell. They can either lose the electrons, or they can gain the electrons, or they can share those electrons, right? We told you metals tend to lose electrons, non-metals tend to gain electrons. Now metals, however, also have a capacity to share those electrons. We also told you that at the right extreme side of the periodic table, there is group 8 or group 0, which is composed of noble gases, and we call them noble since they don't react. We're not saying they don't react at all, but they react the least. Why? Because they have their complete outermost shells, right? So this is what most of the bonding was about back in IGCSE. That was a quick review. Any questions from it?
No, sir.
Okay, so moving on. When elements form compounds, they either gain, lose, or share electrons to get the nearest noble gas configuration. There are exceptions to this rule for some group 15, 16, 17 elements. Not just that, there will be many exceptions with the transition elements. Let me tell you, if you have studied with the right teacher, he or she must have told you that octet and duplet rules are not the universal rules. These are actually the easier ones to begin the student with and to give them the idea about bonding. As soon as we go up, we go to advanced level, they tell you these are not universal rules, and we try to tend to teach you other rules which are more advanced than these. So keep in mind, we are about to break these duplet and octet ideas for advanced learning. Ionic bonding. Ionic bonding is an electrostatic attraction. Cations are positive ions, anions are negative ions. They form an ionic crystal lattice. Covalent bonds between outer electrons of 2 atoms are shared. The ionic or covalent bonds formed are usually strong. It takes a lot of energy to break them. There is also a third form of strong bonding, metallic bonding. These are the ones that we studied back in IGCSE. Now, although the atoms within molecules are kept together by strong covalent bond, the forces between the molecules are weak. We used to call these forces as van der Waals forces. Van der Waals is the term that has hardly been used once or twice in the entire IGCSE book. All right. So the general term to describe them all was intermolecular forces. So let me clarify. The type of bonding we have been discussing previously, ionic, covalent, metallic, these are intramolecular forces. The forces that are actually present inside the molecules, not in between the molecules, inside a molecule. And the terms that we are going to use to describe these will be intermolecular forces, forces in between the molecules. Van der Waals forces is a very good word for that. And they have certain types. The types are, number 1, dipole, instantaneously dipole-induced dipole forces, we call them ID forces. More common name would be London dispersion forces. There are other names as well. We'll get familiar with those once we go into the detail. The second one would be permanent dipole, PD forces. All right, we call them permanent dipole most of the time. And then there is a hydrogen bonding, which is actually a stronger form of PD forces. All right, we are going to go into details of these. Let me tell you, these are not just the only intermolecular forces. There are other intermolecular forces as well, but we're going to begin with these. And if there are any others, we're going to actually make you familiar with those in A2 and not in AS, since these are all explained in AS. So far, we have only listed these over here. Moving on, ionic bonding. So ionic bonding is going to be most of a revision. So I'm going to quickly skim through it. Our ion forms, we know that metals tend to lose electrons. They form positive ions. When an atom loses one or more electrons, you know from the previous chapters that they sometimes also lose their outermost shells. When they do, their size gets smaller. So most of the time, we tend to state that they have smaller sizes than their parent atoms. What I'm trying to say, and what you might need to write, is that cations are smaller than parent atoms. This is something we explain in detail in chapter 2. Ali, we are going to go with this in detail once you go with the recorded videos or with one-on-one classes with me. Negative ions or anions, when an atom gains one or more electrons, non-metal atoms usually tend to do that. They form negative ions, and we call them anions. And let me tell you, anions are usually, I haven't written the safe word here. I tend to ask all my students to do that, so I'm going to do that too. Specifically, use the safe word usually. It would keep you safe from any of the mistakes. Remember, chemistry is full of exceptions. Using a word like usually, rarely, most of the time, some of the times, is a very good way to keep you safe. We call them safe words. You'll learn more and more safe words when you'll go through this AS book with me, and I'll be tending to ask you all the time to use these words, since every time you can't know every single exception, and it would help you to keep your sentences safe and get your marks at the same time, right? So the charge on ions depend upon the number of electrons lost again. You know about that. Positive 2, positive 3, negative 2, negative 3, 2 electrons, 3 electrons lost or gained, respectively. Now, metal combines with non-metals. The electrons in the outer shell of the metal atoms are transferred to non-metal atoms. You know that by dot and cross formula. I hope you understand that sometimes we used to explain stuff like that in this way. Let's say we have Na2O compound, then this kind of diagram back in IGCSE helped you that how this anion comes into being. You know from dots and crosses that it has 6 of its additional electrons and it gained 2. Of course, the formula tells you that 2 electrons were the outermost electrons of the sodium atoms, right? So it gives you the idea. Now, it has complete 8 electrons, configuration of nearest noble gas, not just the electronic configuration of noble gas. Let me tell you, we have been using the word nearest noble gas, all right? So the nearest noble gas to oxygen would be neon, so it's this kind of configuration. Since my example is different from the books, that's why these words in this example might come in different. All right?
Yes, sir.
Good, good. Moving on. The strong force of attraction between positive and negative ion, we used to call that electrostatic force of attraction, and the bond as ionic bond. The ionic bond is sometimes also referred as electrovalent bond. Electro comes from electrons. Valent means valence electrons. Since only the outermost shell electrons uh, were behaving with one another in terms of loss and gain, so electrovalent bond. Don't get confused with this name, since this is another name for ionic bonding. This example clearly tells you what happened. All right. Remember, we used to draw these arrows back in IGCSE, and I usually tend to say that the tail represents the donor of the electron, usually the metals, the head represents the acceptor of the electrons, usually the non-metals, or the tail represents the cations to be formed, and the head represents the anions to be formed, which is pretty much the same thing when we look at it, right?
Yes, sir.
आई होप यहाँ तक सबके लिए क्लियर होगा, बिकॉज ये बहुत इजी पार्ट है, ये हमने पहले भी कई दफा किया होता है, हमें पता है. He's also trying to explain how the formula came into being, Na positive, Cl negative, how we cross multiply these and get our answer, what does electron transfer means, what kind of shape or state do they have. We do know that most of the salts are ionic bonded compounds and they are solid at room temperature. So yeah, most of the ionic compounds are solid at room temperature. Dot and cross diagrams. Dot and cross diagrams are something you're familiar with. He's telling you how to do those. Remember, the dot and cross diagrams in A levels will pretty much be composed of these rules and will not change them. Back in IGCSE, sometimes we ask you to draw all the electrons, but in A levels, it's going to be outer shell electrons only. All right. And the charge of the ion is spread evenly. So we use square brackets. The charge of the ion is written on the top right hand corner. Remember, don't write it over here. That's not the right way. In A levels, this is the right way. Okay. Drawing the brackets, doing them in pairs, top, bottom, right, left. Explain the examiners that you are trying to spread the charge evenly. I've seen students do it like this. Since I'm supposed to draw 7 of these dots and 1 of these crosses, so they do what? They do what? They do it like this: 1, 2, 3, 4, 5, 6, 7, and 1 cross. This means the charge is not spread evenly, and electrons were only present at one part of the shell of the atom, which is a huge mistake in A levels. Do not make that kind of mistake in A levels. This may be acceptable in IGCSE. They may give you a mark for this in IGCSE, but they definitely cut a mark in A levels. In advanced levels, you cannot do your work childishly. All right. I hope I'm pretty clear about this one.
Yes, sir.
Okay.
Yes, sir.
Moving on. Some examples of dot and cross diagrams. We are going to discuss other factors. NaCl is usually the easiest of examples since there is only one electron transferred from Na to Cl, and they tend not to use these kind of examples. Again, this is one of the simplest examples, and simplest examples are not the part of past papers. You'll notice that once you start doing your past paper practice. All right. So Ali, I've recently shared a resource with Liba. It includes all the topical papers from the famous website Save My Exams, which is a paid website. We back in the day we paid for this website. I downloaded all the papers for paper 1 MCQ, for paper 2 theory, for paper 4 theory that is going to help you in A2. And I put all of those papers and their marking schemes on a public storage website. I'm going to send you the link. You can download them all at once, right? This would help you to
All
go
right.
with the topical papers. We discussed those papers in class. I shared the question papers. I share the marking schemes over here. After every chapter, we tend to practice the past paper questions. We weren't used to do that exactly in IGCSE. Maybe you did that at the third year of O levels or IGCSE, but we started from the very beginning in AS, since without this, you won't be able to cope up with AS's syllabus, right? So I'll send you the link right after this class.
Yes. All right, sir. Thank you.
You're welcome. Okay, so magnesium oxide, we specifically catered this example since magnesium is losing 2 electrons. You can see 2 arrows, and oxygen is gaining both of them. A positive 2 and a negative 2 is there for you. All right. It also gives the student the idea that how a positive 2 and a negative 2 simplify in cross multiplication, and we don't get to write Mg2O2. Instead, we write MgO. This is a part of formulation, and we have discussed it back in IGCSE. So I don't think I need to discuss it again. If I do, let me know. Okay,
No, sir.
moving on. Calcium fluoride. Calcium fluoride is an example in which one atom tends to lose 2 electrons and form a positive 2 cation. On the other hand, the other one is simply negative. So we need to balance them with a different number of atoms. This is the first example in which what we do is that we ask our student that there would be 2 fluorine atoms converted into 2 separate fluoride ions from one calcium atom losing both electrons. So at this point, students tend to think that there can be more than one atom in this kind of exercise, and they open their mind towards a whole other set of possibilities. So you will be able to solve the most difficult of examples like this, right? So I tend to ask my students to even solve these difficult examples in IGCSE. So you may not find them as difficult as I'm saying in AS, since you'll find them easy if you've already practiced them, right? There are more questions. You can always practice them. Remember, the book questions are always the easiest. You'll find them a piece of cake, and the past paper questions are always more difficult. You might have studied or seen a lot of memes on social media. Trust me, when it comes to chemistry, book question and chemistry past paper question, those memes are true, right? They tell you how the temperature, the melting point of water or ice in books, and when it comes to past paper, they ask you the radius of sun. So those memes are exactly true. Okay, so covalent bonding. Moving on, single covalent bonds. It's a simple bond pair. It's a single covalent bond sharing of 2 electrons coming from 1 electron from each atom, and this is a specific case for non-metal atoms. All right, a single covalent bond is represented with this kind of line, but what we do in here is that we discuss the bond pairs and the lone pairs of covalent bonds in much more detail than we did back in IGCSE. Bromine, chlorine, iodine are the simplest of examples. We tend to start with the easiest of examples by discussing hydrogen bond, but chlorine or bromine, fluorine, iodine, they're all the same examples as they all tend to form the single covalent bond, right? And this also tells you that how their outer shells are complete after sharing these and they become stable. The configuration of the nearest noble gas. A dotted and cross diagram show the arrangement of electron in the main energy levels. We generally, this means shells, the outermost shell, energy level. Ali, I'm specifically talking about this for you. We generally only show the outer energy level when we draw dot and cross diagrams. Remember that we only draw the electrons as dot and crosses to show which atoms our electrons are from. But that doesn't mean if they come up with a different example, you can draw otherwise. For example, let me consider an example from a past paper, ethanol. It is this kind of formula. Now there are 3 elements. So I tend to ask my students, whenever you are about to draw the whole dot and cross formula for this one, do give a key on the side. You might not want to write these things since they will already be a part of the question, but do give a key at one side of the paper for the examiner, keeping a little bit of a difference for all 3 atoms. This would be a great idea. I've seen students doing that with very neat diagrams. This comes with a practice. So don't just look at it, do it with your own hands, and you'll find that you can do a much neater, quicker drawing when you do this, and you draw a key at either the top left or the top right for the examiner to understand that what you're using. Don't let him struggle with these marks on these portions to get himself to know which ones are which. If you draw it at the top, the examiner will instantly know what you're doing, and he would understand the effectiveness or your brain level working, that you are actually working at an advanced level, at a higher level. He would definitely give you marks. The more you're going to make your work easier for the examiner, the more he's going to be happy and going to give you marks. I've seen students, they do some work and then they mess it all up by cutting it out badly, and then they try to do the work on the sides of the paper like this, which is all messed up, to try to be a little bit clean, a little bit of thinking before you start off with the writing the answer is a very good way. Drawing keys on the side also makes it easier for the examiner, right? It also makes it easier for your brain how you're going to work, since you first draw this and then you start on with the question, you know what you need to do, and you don't have to decide while you are at it. I've seen students, वो यहाँ पे शुरू करते हैं, एक को ये ड्रॉ करना शुरू करते हैं, ये उसने एक सर्कल किया, एक ओवरलैप किया, फिर वो सोचता है एक मिनट के लिए मैंने डॉट्स डाल दिए, मैंने क्रॉस डालने, and at this point when you are under pressure in exam and you are supposed to manage time, maybe during that thinking you make a mistake. Doing it at first will keep you away from the mistakes. All right, so it's not just a trick to trap the examiner for showing a better efficiency or a higher order thinking towards your answers. It's also actually tricking your own brain into not making the mistakes, since you have already decided what you're supposed to do in next 1 or 2 minutes, right? Use a dot for electrons for one of the atom and cross from the other if there are more than 2 types. Small circles, small triangles are good. I do not agree with triangles, since I've seen students draw triangles like these and circle like these in such a way that their circles and their triangles mix up. Do not draw any of the symbols that you mix up. All right, I've seen students, they write this as X and then this is their multiplication sign. If you can't help yourself with your writing styles, and if you can't write X like this and multiply like this to make it easier for the examiner what you're writing, you might not be able to come up with this differentiation as well. So don't go for triangles and circles and rectangles if you cannot differentiate it. And even if you can differentiate, but you're going to waste 5 minutes on a 1 mark or a 2 mark question, that's a stupid idea. So don't go for that. Hence the key at the start. So we have hydrogen, we have methane, we have water, we have ammonia, the examples, and here you'd notice that they have specifically been drawing that. All right, you would notice something, that for the lone pairs, they draw the single lone pair on a nitrogen atom in case of ammonia. They draw 2 lone pairs on oxygen in case of water, but they do not draw 3 lone pairs in case of fluorine in hydrogen chloride. Remember, in chemistry, and I'm going to explain it to you further once we get to that page on the same chapter, 1 lone pair may matter and may be used in another kind of bonding, which we'll study in this book, which we haven't studied back in IGCSE. Or 2 lone pairs may also be used for the same thing. We're not going to use 3 lone pairs, and so that's why worldwide it's not a convention to draw 3 lone pairs. You can draw those, that won't be incorrect, but it's not a convention, so we're not going to waste time on that. Are we clear? Are we all on the same page?
Yes, sir.
Yes, sir.
Good, good. So if there is 1 lone pair, do draw it. Do never skip it, since you may get your marks cut for that. If there are 2 lone pairs, do draw it. By that I mean any group 5 member will have 1 lone pair, any group 6 member or 16 member will have 2 lone pairs, any group 17 members will always have 3 lone pairs, but we're not going to draw them. All right, so it's easier in terms of groups to remember which atoms we're going to draw lone pairs with and which atoms we're going to simply leave them as a part of the convention. Then we have ethane like this. There are some cases in which electrons around the central atom may not have a noble gas configuration on an octet. All right. Now, there are 2 possible cases. We may not be even able to reach the octet. We may be deficient of electrons, or we may surpass the octet and we may have more electrons than 8 electrons in the outermost shell. Let's consider both cases. Let's start with the former one first. Boron trifluoride. Now, I hope you remember that boron belongs to group 3 or group 13, which means it has 3 electrons in its outermost shell. Has only 6 electrons around the boron atom. It would share every of its dot with one of the crosses from 3 fluorine atoms, all right? So there are 6 electrons. We call it electron deficient species, since the octet is not complete. It is one of the examples in which octet is not complete. Since I am trying to emphasize upon boron on group 3, any group 3 element, when it is targeting halogens, in the similar case, if we talk about AlCl3, or if we talk about any compound of any halogen with aluminum or boron or any member from group 13, it would be electron deficient in the same way. Make sense?
Yes, sir.
If I talk about group 5 or 15 or group 6 or 16 elements with halogens again, sulfur hexafluoride, HF6, has 12 electrons around the central atom. Since sulfur has six electrons, and each of them can be shared with the outermost of a fluorine and six fluorine atoms separately around the whole system, you would notice that sulfur is actually surpassing the octet and has 12 electrons in its outermost shell instead of 8. We call this an expanded octet. An expanded octet is something that has anything more than 8 electrons. It may have 10, it may have 12. Right? Another example would be phosphorus 5 chloride, or any chloride or any halogen compound with group 5 atoms. It can be nitrogen, it can be phosphorus, it can be anyone from the list beneath phosphorus. Now it has 10 electrons, PCl5. Phosphorus has 5 electrons, each of them is shared with one of the chlorines, and the central atom would have an expanded octet having 10 electrons in an outermost shell. Make sense?
Yes, sir.
Good. Sulfur dioxide. Sulfur atom forms a double bond with each oxygen atom. This leaves a pair of non-bonding electrons on the sulfur atoms. There are 10 electrons around the sulfur atom. This is something like this. A double bond with one oxygen, another double bond with another oxygen, and then a lone pair. Take a look. There are 10. Right? Again, an expanded octet. So boron trifluoride, sulfur hexafluoride, phosphorus pentachloride, and then sulfur dioxide. So since elements in periods, okay, this one is a mistake in the book. I'd like to correct it. I don't really know if you have the same mistakes. It's actually groups 15, 16, and 17. We don't have anything about group period 7 so far. All right. So groups 15, 16, and 17 have more than 8 electrons in their outermost shell. So what happens is that they have expanded octets most of the time when they are bonded, of course. So according to one theory, they use unfilled p orbitals and d orbitals in the third main energy level for their extra electrons. Some common examples of this expansion of octet is phosphorus, sulfur, and chlorine with oxygen or fluorine. All right. Ali, this might come difficult to you since you're not done with chapter 1 and 2. LIBA, for you, anything unfilled would be occupied. Let me clear this one up by actually giving you an example. Let's talk about sulfur hexafluoride. Sulfur is 16. That means 1 is 2, 2 is 2, 2p6, 3 is 2. And how much would be the last one?
Four.
Right. 4. So, which means if there are extra electrons coming from fluorine and we have these, sorry, I was supposed to mark the process. So, my bad. So, 6 fluorine atoms are coming up. Where are they going to stay? 2 of these would stay over here, and this becomes 6. And then we have another part of the subshell that was lying around empty. We can start filling in those. It's not that this 3d10 would be completely filled. I'm not saying that. By that, I mean that we have a vacant space for 10 more electrons. Since we use 2 of them over here, so there will be 4 over here. This is what this sentence meant when they were talking about expanded octets and having some subshells or orbitals lying around free that were never filled. They can start filling up those. Make sense? फ्लोरीन के
Sir,
इलेक्ट्रॉन्स
why
को जी कहें
not 3s2 and 2p6?
मैं समझा नहीं सॉरी
Sir, आपने 3d10 को फिल करना शुरू किया है ना?
तो 3s2 तो पहले ही फिल हुआ है
Oh yes. Okay, sir.
3s2 और 3p में ऑलरेडी 4 थे 3p में वेकेंट स्पेस सिर्फ 2 इलेक्ट्रॉन्स की है तो 6 फ्लोरीन एटम्स के जो 6 इलेक्ट्रॉन्स हैं उनमें से 2 इलेक्ट्रॉन्स मैं पुट अप कर दूंगा 3p में 3p6 तक पूरा फिल हो जाएगा ठीक है अभी भी हमारे पास 4 इलेक्ट्रॉन्स बचते हैं तो 3d10 में से जिसमें 10 की स्पेस होती है एक्चुअली उसमें से सिर्फ 4 फिल अप होंगे That's what I've been trying to say. So you would get an idea कि अभी भी हमारे पास third shell में कोई sub shell vacant पड़ा है. So if there are any incoming electrons, they already have the space to fill. If you were trying to say, अगर आप इसकी बात नहीं कर रहे थे और आप ये कहना चाह रहे हैं, maybe आपके ज़हन में ये बात आई हो कि 3p6 के बाद normally हम 4s2 fill करते हैं. 3d10 तो बाद में fill करने की बारी आती है, energy wise पहले इसकी बारी आती है, ठीक है? अगर आपके ज़हन में ये क्वेश्चन है तो याद रखिए कि ये एक ऐसा एलिमेंट है जो थर्ड पीरियड में एग्जिस्ट करता है which means कि इसके पास सिर्फ 3 शेल होते हैं तो एक्चुअली इसके पास 4s2 अभी है ही नहीं कि वो फेल हो तो लिहाजा 3d10 फेल होता है आपकी अंडरस्टैंडिंग के लिए आई एम नॉट सेइंग ये एग्जैक्टली इसी तरह की चीज होती है एडवांस लेवल में बच्चे को आइडिया के लिए ये बात समझा दी जाती है टू बी ऑनेस्ट this is still in a discussion with scientists if you're going to YouTube it you'll find a lot of theories. Some of them have been accepted by most of the scientists around the world, ठीक है लेकिन 4s2 फिल होगा 3d फिल होगा 3d फिल में कौन से सब शेल्स होंगे लाइक केला होगा या 3p5 और 3d5 होगा there are a lot of discussions on the internet so I'm not going to go into details since that's not a part of your course and that's actually beyond the requirements but what we're trying to say is that any incoming electrons have already some vacant space to fill that's it. What space do they fill? We're not going to go into that kind of discussion, and that won't be a part of question in exams as well. At least I haven't seen a question like this in past 8 years or so. Make sense?
Yes, sir.
Great. Ali, I do understand it might be a little confusing, but once you go with this, you will understand it better. Don't worry. We'll cater it.
All right, sir.
Okay. So then we have multiple covalent bonds, we have double covalent bond, we have triple covalent bond. You already understand double covalent bond is actually a composition of 4 electrons, 2 of which comes from each side of the atom. All right. So oxygen-oxygen double bond or carbon-carbon double bond, carbon-oxygen double bond, or nitrogen-nitrogen triple bond are very good examples of these. Since we have done all of these examples in our previous course, O levels or IGCSE, so now I'm not explaining anything over here. You would also notice that they are not discussing anything extra. They're not discussing anything about lone pairs over here. So you won't need to do that either. Sometimes the students tend to ask me that, are we supposed to draw the lone pairs over here? The book is not drawing these. Since the book is not discussing these specifically, that's why the book has left it. Are you supposed to draw it in exams? Yes, you're supposed to do, since you are supposed to show your complete concept to the examiner. Is that mandatory in a question? To be exact, no. If your question requires it, go ahead, do it. If a question does not require it and you want to be safe, go ahead, do it too. And if your question does not require it and you leave it somehow and you're pretty sure that that won't be a part of the marking scheme, that's fine. You're managing time. Sometimes the question space and the answers and the marks given for the question gives you an idea about the time management, whether you can leave it or not. In case if you're leaving it, then that's all right. Okay. But we do ask our students to be in a habit of drawing these, since if you're in a habit, you'll do it quickly without even thinking that I need to do it or not. Since that only takes hardly 8 to 10 seconds, and you can always manage 8 to 10 seconds in a paper. Talking about seconds gives the impression, passes on the impression from the teacher to the students that A-level paper is going to be scary. I'm not scaring you out, but that's a harsh fact you need to face. It would be a race against time. The better you're prepared, the good you'll be doing on your result, right?
Yes.
Okay, it's about time, so I am going to stop right over here since the name